I've been at the library all day, and guess what I found?
You always tell that. But really, Lila, all the things you are saying are not fascinating.
That may be true, but listen, I'm sure this is much pretty interesting.
Then what is it?
Haven't you wondered about Damascus? We're seniors, but we've never been there before.
All I know is we're off limits there. Unless you don't want too much for graduation.
It's indeed off limits because you won't believe what's inside it. Are you with me?
Are you sure you checked the perimeter? Oh, Lila, if we got caught, I'd kill you!
Here it is. This is why students are restricted to this area.
Haha, I'd increase my candidacy for cum laude for one of your jokes, Lila. Let's go.
No, this is legit. In Godkey's timeless book, I saw its blueprint. It has been kept for so long and it has made nearly 100 transportations back in time since 1997. Although, 75% of those weren't able to transport back to the present. Until now, some professors in this school, just like Mr. Riley, are trying to fix it with the hope of that missing persons could be rescued. They are finding the right algorithm to safely travel back in time and even to the future.
Oh, you know how we can prove if this is an actual time machine, right?
There's no other way. So, when do you want to go back in time?
How about when dinosaurs are still existing?
Oh, Ron, we're gonna be dead by the time we go back to the present.
Let's go to Wilhelm Röntgen's time instead.
That's a good idea.
Friends, this is reality. Beneath our skin, beneath every dust, is an unseen and indivisible particle, atomon, the atom.
And these atoms compose of four substances: earth, fire, water, air. Therefore, we are beings of elements.
I think this is when the Greeks were still sympathizing their thoughts about the atom.
Hello, I am Fuzzy, your time service for this travel in time.
So it is true. That device really offers a guide.
Yes, and I am trained to censor your interest. You pushed to go to 1895, but I redirected you here in Greece to start from the very beginning and trace the essence of radiology to the present.
That sounds fun. Bring us to the next one.
Honorable scientists, meet some friends from the present.
I may only be an English school teacher, but take a look at my published book.
I believe elements could be classified according to integral values of atomic mass. The atoms of an element are alike in the way that they reacted in the same way chemically. Each element, however, is unique from each other. When two elements are combined, they form an eye and hook affair.
For me, if you have seen a plum pudding, you have basically seen an atom. The pudding being a shapeless mass of uniform positive electrification, while the plum were the electrons. This is when I deducted the electrons are very integral to an atom, and the charge of atom is actually neutral.
Thomson's model was lacking. From my investigations, the atom does not only contain electrons, but it has a small, dense, positively charged center called the nucleus. This nucleus is then surrounded by a cloud of electrons.
My idea is so close to Rutherford's, except that the electrons should be revolving around the nucleus in prescribed orbits or energy levels and not just merely clouding it. It looks like our solar system with the nucleus as the sun and the electrons as the planets.
I can see anything. Lila, where are you?
I'm only beside you, Ron. Fuzzy, where are we?
Since you've known about the atom now, you're ready to meet the father of radiology.
Oh my gosh! Ron, we are in Germany!
I get it. It's so dark because we are in the laboratory of Roentgen.
Born on March 27, 1845, at Lennep in the Lower Rhine province of Germany. As the only child of merchant in and the manufacturer of cloth, my mother was Charlotte Constance Rowan of Amsterdam, a member of an old Lennep family which had settled in Amsterdam. When I was 3 years old, my family moved to Apeldoorn in Netherlands, where he went to the Institute of Martinus Herman van Doorn, a boarding school. According to my school, I did not show any special aptitude, but showed a love of nature and was fond of roaming in the open country and forests. I was especially up at making mechanical contrivances, characteristics which remained with me also in later life. In 1862, I entered the technical school at Utrecht, where I was however unfairly expelled, accused of having produced a caricature of one of the teachers, which was in fact done by someone else. My first work was published in 1870, dealing with the specific heats of gases, followed a few years later by a paper on the thermal conductivity of crystals. Among other problems I studied were the electrical and other characteristics of quartz, the influence of pressure on the refractive indices of various fluids, the modification of the plane's polarized light by electromagnetic influences, the variations in the functions of the temperature and the compressibility of water and other fluids, the phenomena accompanying the spreading of oil drops on water. The peak of my career, however, was my discovery of the rays that I called X-rays. On the evening of November 8, 1895, I found that if the discharge tube is enclosed in a sealed, thick black carton to exclude all light, and if I work in a dark room, a paper plate covered on one side with barium platina cyanide placed in the path of the rays became fluorescent even when it was as far as 2 meters from the discharge tube. During subsequent experiments, I found that objects of different thicknesses interposed in the path of the rays showed variable transparency to them when recorded on a photographic plate. When I immobilized for some moments the hand of my wife in the path of the rays over a photographic plate, I observed after a development of the plate an image of my wife's hand which showed the shadows thrown by the bones of her hand and that of a ring she was wearing, surrounded by the penumbra of the flesh, which was more permeable to the rays and therefore threw a fainter shadow. This was the first röntgenogram ever taken. In further experiments, I showed that the new rays are produced by the impact of cathode rays on a material object. Because their nature was then unknown, I gave them the name X-rays.
Kazi, is this the real Roentgen?
What are you talking about, Lila? You're gonna doubt at this point?
There's no doubt he is Roentgen, the great mind behind the X-ray.
Hello there. I've known that you are both studying radiologic technology.
Oh yes, your discovery is very much useful at the present time. Without X-rays, the longevity of humanity may be too short.
I knew that X-ray would be that beneficial to the medical field. But if not of the concept of electricity and magnetism, the understanding on X-rays wouldn't be that refined.
X-rays being a form of electromagnetic radiation, both exemplify electric and magnetic properties. That's why our next destination is when electricity and magnetism are respectively discovered. Beep beep.
Goodbye, Roentgen!
Fortunately for us, magnetism was discovered. As early as 550 BC, the Greeks knew that a naturally occurring mineral called magnetite or lodestone had a mysterious attraction for iron. They called the lodestone a magnet because it was originally found near Magnesia in Turkey. By 1050 AD, it was known that a piece of lodestone suspended in the center would gradually swivel until it pointed in a north-south direction. Soon sailors were using lodestone for navigation. Early compasses consisted of lodestone attached to a piece of wood, floating in water so that it was free to rotate. These mysterious pieces of stone advanced sea exploration as never before. Way, magnetism is similar to the forces that charged particles exert on each other. These forces act over a distance in the same mysterious way. During the 17th and 18th centuries, electricity and magnetism developed as separate sciences and were believed to be unrelated. Then, in 1800, Alessandro Volta developed a device that paved the way for a change in this view. His device consisted of copper and silver coins, arranged in a column and separated by pieces of cardboard soaked in salt water. When he attached a conductor to the top and bottom, like this, and brought the two ends together, a spark resulted, indicating that a flow of charge was occurring. Volta's work eventually led to the development of batteries, which could be used as sources of continuous charge flow. A battery like this was used by Danish physicist Hans Christian Ørsted in 1819 to conduct an experiment in which he hoped to prove conclusively that electricity and magnetism were not related. At first, the demonstration seemed to work. When the switch was closed, the compass needle, which was perpendicular to the conductor, didn't move at all. However, when Professor Orsted repeated the experiment, this time with the needle parallel to the conductor, and the switch was closed, the compass needle reacted instantly. So it seemed obvious that electricity and magnetism were somehow related.
One eternity later.
The medical field is in danger. Doctors are panicking as to how they can give optimum healthcare service to millions of patients around the world if they don't have an equipment to help them through their diagnosis. And so, X-ray tube parts, they need your help.
Anode. Anode represents the component in which the X-ray is produced. It is a piece of metal shaped in the form of a beveled disc with a diameter between 55 mm and 10 mm, 77 mm thickness, connected the positive side of electrical circuit. The anode converts the energy of the electrons into X-ray and dissipates the heat, considered the byproduct. The two categories of X-ray anodes are stationary and rotating anode. The main difference here is that one anode stays still while the other spins around a fixed point.
Hi, I'm cathode and I am the negative charge of the X-ray tube. Its major parts are the filament and the focusing cup.
Glass enclosure is a special type of vacuum tube that contains the two electrodes, the cathode and the anode. It is made up of Pyrex glass to enable it withstand the tremendous heat produced during X-ray.
I'm protective housing. I'm used to guard against excessive radiation exposure and electric shock.
so much from this trip.
I also had fun.
But how are we going to the present?
That's the problem.
Laila, I need to march as cum laude. I can't be trapped here forever.
Me too. Just like you guys. I'm a student of St. Paul University, Philippines, and I have traveled back in time. Beep beep.
So, you're saying you are not robot at all?
No, I'm not. I was trapped. Nobody safely traveled back in time. I was lucky because I get to be fuzzy, but others, beep beep, they are lost internally.
But how about us? Are we gonna be fuzzy 2 and 3? Oh no.
No, beep beep, there's a way back to the present.
How?
You need to deactivate me.
But if we do that, it would mean we'll kill you.
Yes, beep beep.
That's not fair. We're your friends. We can't do that.
But I'm too old and you're young. I need to save you because soon you are going to save lives back in the real world. So go ahead, beep 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 beep.
Oh, Fuzzy.
Thank you. Thank you for this selfless act.